Hi, my name is Bloatfish and welcome to my video on redstone powering methods. This video will cover powering methods such as hard powering, soft powering, vertical and quasi powering. And also one more thing, I may go off topic a bit to clarify some information I missed last video because I'm bad at planning stuff, so I'm sorry. So without further ado, let's get started. We have two different types of basic powering, so soft powering and hard powering. Soft powering involves a redstone wire going into a block, so in this case, this block will be considered soft powered. Now, what will a soft powered block do? Like, it powers adjacent components like this, and also you can get an output from it using a repeater, just like that. The only limitation is that you can't power adjacent, like redstone wires, because it's just soft powered. However, a hard powers block does the same thing, except for it can also power adjacent redstone wires like that, and this repeaters, adjacent components, and all that stuff. One more thing. To hard power a block, you don't have to use a repeater. You can always use like any other thing. So, for example, the observer would be another way to hard power a block, like that. You can see it's hard powered, but it's just that redstone dust doesn't work because redstone does soft powers, and repeaters and any other components that have a signal will hard power. Here are two extended diagrams of a soft powered block and a hard powered block. You can see in the soft powered block that this soft powered block can power adjacent components and also repeater, but cannot power redstone like that. Sideways or below cannot do that. However, a hard powered block can do everything. Components, repeater, and then redstone sideways or even below. Something interesting here is that a redstone block, which I have not mentioned before, can act as a mobile hard powered block, as like a redstone source. So you can power redstone below, repeater, components, and even sideways, just like this. And yeah. So this machine is an example of how to use soft powering effectively and also a waste of redstone. If we power this machine, then you can see it just spits out diamonds, a very common sight in your average survival world. So we can actually cut the amount of redstone used in half, and the circuit would still work. But why is this? Because this line of redstone wire is actually soft powering this line of blocks, so these 5 blocks. So these 5 soft powered blocks will power the adjacent blocks, so these 5 blocks. So therefore the whole 10 blocks are powered, and this machine works just like that. And I get all the diamonds. Now on to the next major type of powering, which would be directional powering. Directional powering can be split into 2 different parts, like vertical and horizontal. Horizontal is pretty self-explanatory. It's just like a redstone source with some redstone dust and a repeater of some sorts, just transmitted horizontally. Nothing too special. However, vertical transmission can be into 2 directions, up and down. So here I've made 5 circuits of examples, and the circuits in green can transmit signals up and down, while the circuits in blue can only transmit signals upwards, well, they're usually transmitted upwards. So for the first example, we have a leaf tower. These leaves can actually transmit a signal if I just flick this lever, just like that. There's a maximum range of 6 leaf blocks it can travel, and so the observer can detect the changes to the leaves by this oak log, like that. It's nothing too special. It can burn down really easily. That's all I need to say. Second of all, we have a slime block tower with a redstone block on top. It can provide a constant power source like that. However, slime blocks will interact with the surroundings, so they move or push blocks, so not really good to work with. The third example, we have an observer tower, but I've replaced some observers with doors, which can still update the observers without while cutting costs, because observers are very expensive, like that. And on to the more conventional ones. We have the Redstone Torch tower and using half blocks to transmit signals. For this Redstone Torch tower, we just have redstone torches powering the block or unpowering the block, so the next redstone torch can be switched on. So for example, when this redstone torch is switched off, then this block is unpowered, so this redstone torch is powered. So when this torch is powered, this block is powered, so this redstone torch turns off. So it's just a continuous cycle. This can be transmitted downwards, but it's kind of inconvenient. Not many people use this. And then finally we have the half blocks. Like for the half blocks, redstone signals can be transmitted diagonally like this until it reaches the source. But the only limitation to this is that of the redstone signal strength, which can only reach 15. So like after this redstone travels 15 blocks, it doesn't work anymore, and it also cannot transmit downwards like that. So that's like a small summary of directional powering. Sometimes when your redstone signal strength starts to run out, you may have to rely on signal strength extenders or constant powering to have a signal again. So people usually use repeaters, this will extend the redstone signal strength back to 15, like no matter what signal strength you are at like currently. And then like people always use like levers, buttons, pressure plates as a constant power source. And there's also like redstone torches, redstone blocks. Some people even use detector rails. This can be used to power TNT and TNT duplicators. It's like a glitch. And also like sunlight detectors like that. It's not really constant, but like it's on and off, but it can still be used. But some people may not know that you can actually get power sources from some more abnormal blocks. So for example, like most blocks that can hold items, so chests, minecart chests, with the exception of with the ender chest, which does not interact with anything, but like this can also be replaced with a furnace that can detect an item. And yeah, we can also use item frames, which will give out a signal strength correspondent to what like orientation the item is in. Then lecterns, dependent on what page we are on, and then finally composters, and even cauldrons, which I seem to have forgotten to put here. So yeah, composters depending on how much bone meal there is. So like you can see there are like different layers. So this is like the final layer, and yeah, that's like a small summary of constant power sources. And also one more thing, like the main reason why we use a constant power source is that they can give out varying levels of redstone signal strength. So like usually a redstone torch or redstone block will only give out a 15 like signal strength, but however things like lecterns and composters can give out signal strengths as like, for example, like a 1 signal strength. If I just put like 1 block inside, you can see that, wait no sorry, like this, it only like gives out a 1 signal strength, like that. So because it's like a weaker signal strength, so like that's why we use these constant power sources. Now onto the final type of powering, called quasi powering. Now this is like a kind of special type of powering which originates from like the idea that blocks can update 1 block further. So like if you look at this example over here, you can see that this block of redstone is actually like 1 block away from this piston. However, if I update this piston, then you can see that it still extends, because like this redstone block is still powering this piston. It's just like 1 block away, so it's kind of weird. So this is like how quasi powering originates. You can see over here, if I power this lever, then you would expect only like the top piston to extend, but this is not the case. If like this lever, this block will be hard powered, but like both pistons will extend at the same time. This is because like of quasi powering, and because like this block can like detect the update from 1 block away, so it's like diagonal, so it's 1 block like that. So if I just dissect this diagram for a bit, you can see that if I power this block, nothing happens, because like this block has to be updated, like how I used the fire charge. So if I just update this block, you can see that the piston is actually powered. If I like flick the lever again, it's actually depowered, but only until I update the block again, like that. So this is like quasi powering. It can only like work downwards though. So if you look over here, it cannot work upwards. So it cannot power the block above, only downwards. So only this works. But like you can see, like because of like that scenario, like with the slime blocks and pistons, that this also works too, because like it's still like 1 block of further, so this piston also extends. So how's this used in a normal redstone contraption? You can see behind here, this is like a very easy piston door, and if I just flick this lever, like this works. It's because of quasi powering. It's similar to like this scenario where like this block is soft powered, so like this can power the blocks beneath them, just like that. And that's like a small summary of quasi powering. Now on to some other examples of powering methods. In the first example, you can see that we have a redstone torch inside the circuit. So it's like, it's not the initial powering source, but like it's inside. So like the main reason we use a redstone torch is to invert the signal like this. So like when this block is off, then like this redstone torch is on, so naturally it powers the signal. But when this block is powered, then this redstone dust will be on, so this piston is powered like that. And then we also have this, where if I just flick this monostable, then you can see because like this piston spit out its block, then like this redstone torch will be able to hard power this block, and then this block be hard powered, which will power like alternate components, so this redstone lamp is powered. Also, using like different powering methods, we can actually transmit signals directly above and below each other. Like this, you can see that these two literally transmit signals up and downwards, and they don't interfere with each other, like that. It's very convenient. Of course, you can use like observer lines, but like if you don't have observers available, then this can be used too, like that. Now for the final example, which is a reason why we use these varying signal strengths using a comparator. And yeah, so like how a comparator works, like in its default state, is it compares the inputs from the side and the rear. So if we look over here, like this lectern is at 15, so therefore like it will output a signal strength of 15 on the side. So like if the signal strength on the side is larger than of the rear, then it won't like power. So for example, if I just power this, it won't work because like this lever is actually powering this redstone. This does for 15 and then 14. So like a 14 signal strength is going inside, and this is a 15 signal strength. So like the side is bigger than the rear, and so therefore it won't have an output. However, if I just put a 15 signal strength back into the rear, like it'll work because like they're the same signal strength, and it works like that. So this is like why we use a constant power source, because it has like a varying signal strength. So that's my video on redstone powering methods. I hope you learned something, and if you have any inquiries or questions, just leave them down in the comments. Thank you for watching.